So this is a side view here. Let me show you what the top view looks like. This is welded there. Okay. So that's the top view of it. So let me label these here. Here's 2. Here's 3. Here's 4. Here's 5. And I have omega 2. Let's say it's going like this. And omega 3 and 4 are compound gears. So this is omega 3, comma 4. Then omega 5 is going like this. All right. So note, gear 3 and 4 are compound gears carried on the same shaft. Okay? So let me stop there just for a second. Make sure everyone understands what I'm drawing. So gear 2 is mating with gear 3 at pitch point P. All right? So this is pitch point P. Then this gear here, okay, which is being carried by the same shaft, mates at Q. So this is Q. All right? And that drives 5. So now let's see what happens with this when we look at it mathematically.
This may be a silly question, but is 2 the pinion or is 4 the pinion?
2 is the pinion,
Okay.
mating with this gear. 4 is the pinion, mating with this gear.
So you can have more than one, okay.
Is, where's the pinion?
The smaller of the 2 gears of the meshings is called the pinion,
So the pinion.
and the bigger of the 2 meshing gears is called the gear. I know that the nomenclature is not good. Right?
Is gear 4 placed on gear 3? Are they on top of each other?
Gear 3 and 4. So I'm looking at the top view of it here,
Okay.
okay? And so here's gear 3 right here,
Oh, okay.
and here's, and then here's gear 4. So let me label that. Here's 3 here,
Because they have the same omega.
and here is 4,
One
and here is 5.
on
Okay? So if this thing here is rotating this way, then the velocity of P is going straight up. So the velocity of P equals omega 2 times R2, which equals minus omega 3, 4 times R3. That's at P for 2 and 3 meet. Now, if I look at this one here, this is the velocity of Q. The velocity of Q equals minus omega 3, 4 times R4, not R3, but R4, which equals omega 5 times R5. That's at Q where 4 and 5 meet. All right. So now let me do the omega out over omega in thing again. Omega out over omega in equals minus omega 3, 4 over omega 2. So you always put the output on top, input on bottom, times minus omega 5 over omega 3, 4, which equals, so if you look at this, you may look at this and go, oh, this is the same thing's going to happen. I'm going to have all those things drop out. But watch what happens here. This actually turns out to be minus R2 over R3 minus R4 over R5. So they're not dropping out now. Okay? Which really means omega out over omega in equals minus N2 over N3 minus N4 over N5. All right? So you'll notice that you have a positive, it turns out to be a positive number here. You have a positive omega 2, you have a positive omega 5, that's good, the math proves it, and the influence is now not canceling out, it's still there. Every gear contributes to the gear train, not only in direction but also the gear train value. Okay, how are we doing on time? All right, so what I'll do next time is I'm going to do a problem. So you may want to let's do homework problems, first two homework problems. And